There is a silence in the deep void of space that is occasionally broken not by sound, but by the screaming presence of something that simply should not exist. We look to the heavens expecting order. We expect the celestial mechanics of the universe to follow the rigid, predictable laws of physics that we have spent centuries refining. But every once in a long while, the dark curtain of the cosmos pulls back to reveal an actor that refuses to follow the script. We have received new, startling data regarding the interstellar object known as 3I Atlas, and the implications are sending tremors through the astrophysical community. Harvard scientist Avi Loeb has stepped forward to illuminate a reality that is as fascinating as it is unsettling. We are looking at an object that appears to be violating the standard model of cometary physics. When our most powerful telescopes peer into the abyss to lock onto 3I Atlas, they expect to resolve a nucleus, a solid, dirty snowball characteristic of comets. Instead, they are met with a ghost. They see a luminous, glowing cloud, a phantom entity where a solid rock should be. The data reveals a significant problem. Almost 100% of the light we are capturing is not reflecting off a solid surface, but is instead bouncing off a chaotic swarm of dust particles surrounding the object. Hubble, the veteran eye in the sky, attempted to pierce this veil back in July, trying to measure the heart of this traveler. The results were inconclusive, offering a massive range of possibilities that effectively told us nothing. The dust cloud is so incredibly dense, so brilliant in its scattering of light, that it is drowning out the object itself. Avi Loeb has described this phenomenon as a veil. We are staring at a cosmic mask. We are witnessing the collective glow of quintillions of microscopic specks, yet we are entirely blind to the architect of that cloud. This is not normal behavior. When we observe the comets native to our own solar system, the nucleus is usually distinct. Yes, there is a coma, a halo of gas and dust, but the solid heart remains visible. With 3I Atlas, the dust has formed an optical fortress. The nucleus is gone, hidden behind a wall of light. This presents a staggering challenge for astronomers. If the veil is impenetrable, how can we possibly know the true dimensions of 3I Atlas? Scientists have attempted to reverse engineer the size based on the brightness of the glow, but they have hit a mathematical dead end. The brightness we observe could be the result of two radically different realities, and we have no way to distinguish between them. In the first scenario, 3I Atlas is a behemoth, a massive solid object, perhaps 20 kilometers across, surrounded by a thin wisp of dust. In this version, the light is reflecting off the rock itself. In the second, more unsettling scenario, the object is tiny, maybe only 1 or 2 kilometers wide, but it is churning out a monstrous, hyperactive cloud of dust. In this version, the light is scattering off the particles. To our telescopes, these two realities look exactly the same. We are effectively blind, staring at a light in the fog, unable to tell if it is a flashlight 10 feet away or a lighthouse a mile out at sea. The only way to solve this riddle is to stop looking at the object and start looking at the dust itself. And that is where the story shifts from a difficult observation to a physics-defying mystery. If you enjoy deep dives into the most profound mysteries of our universe, and if you want to stay ahead of the curve on the strange phenomena entering our solar system, make sure to subscribe to the channel. We are tracking these anomalies closely, and you won't want to miss what comes next. To understand why 3I Atlas is so strange, we have to talk about the behavior of dust in a vacuum. A typical comet, the kind we have studied for decades, sheds dust particles that are incredibly small, about half a micron in diameter. To visualize this, take a human hair and slice it lengthwise 100 times. That is the scale we are talking about. These submicron particles are the perfect size to interact with visible light, which is why comet tails are so spectacular. They catch the sunlight and scatter it, creating those long, beautiful streaks across the night sky. The interstellar medium, The vast emptiness between the stars is also filled with this kind of fine dust. It is the cosmic norm. However, the dust shrouding 3I Atlas is breaking the rules. Avi Loeb ran the numbers, calculating the necessary size of these particles based on the physical forces acting upon them. The results were shocking. These are not the wispy smoke particles of a normal comet. The dust surrounding 3I Atlas is massive, relatively speaking. The calculations suggest particles at least 10 microns in radius, with some potentially reaching up to 100 microns. You might wonder why the difference between half a micron and 10 microns matters. In the grand scheme of things, both are invisible to the naked eye. But in the violent environment of space, size is everything. It dictates destiny. When a photon of sunlight strikes a tiny half-micron particle, it imparts momentum. Because the particle is so light that radiation pressure is overwhelming. It is like a gale-force wind hitting a speck of ash. The particle is instantly blown backward, away from the sun, forming the classic tail that trails behind the comet. This happens rapidly, often within a single day. But when sunlight hits a 10-micron particle, the physics changes. A 10-micron particle is 20 times wider than a half-micron one, but since mass is determined by volume, and volume is the radius cubed, that particle is 8,000 times heavier. Imagine the difference between trying to blow a feather off your desk and trying to blow a bowling ball. The feather flies away instantly. The bowling ball sits there, unmoved. These heavy 10-micron particles around 3I Atlas are the bowling balls. They are so massive that the pressure of sunlight cannot easily push them around. They can travel toward the sun, fighting against the solar wind for hundreds of thousands of kilometers before the radiation pressure finally slows them down and reverses their course. This is not theoretical. This is exactly what we are seeing. 3I Atlas is projecting a sunward jet, a spear of material pointing directly at the star it is orbiting. This jet stretches for at least 400,000 kilometers, roughly the distance between the Earth and the Moon. This sunward jet has been a persistent feature. It was visible in July. It remained in September. It survived the object's closest approach to the Sun in November, and it persists now. For a jet to maintain this structure, to point directly into the teeth of the solar wind and stay collimated, meaning focused in a tight, narrow beam, over such a vast distance is bordering on the impossible for a standard comet. The solar wind is not a gentle breeze. It is a torrent of charged particles moving at 800,000 miles per hour. For the ejected material of 3I Atlas to push upstream against this river and stay bound together in a beam with an opening angle of only 8 degrees is extraordinary. Normal comet tails fan out. They get fuzzy. They disperse. This jet remains focused like a laser beam across the void. Avi Loeb's mathematical analysis of this jet provides us with a very specific constraint on what this dust must be. The particles are locked into a Goldilocks zone of size. They cannot be smaller than 1 micron. If they were, the solar radiation would simply stop them dead in their tracks. The equation governing this is straightforward. The distance a particle can travel upstream is determined by its launch speed and the deceleration force of the Sun. For a sub-micron particle to travel as far as we see this jet extending, it would need to be launched from the surface of 3I Atlas at speeds that exceed the thermal limits of gas. It would require a velocity that is physically impossible for a natural sublimation process to achieve. Therefore, the particles must be large. However, they cannot be too large. They cannot exceed 100 microns. This is because dust is not launched by itself. It is dragged off the surface by escaping gas. As the ice on the comet turns to steam, it rushes outwards, carrying dust with it. But gas drag has limits. It cannot lift a boulder. The larger the particle, the harder it is to lift. For particles larger than 100 microns to be ejected, the nucleus of the comet would have to be incredibly small, less than 100 meters across, for the gravity to be weak enough to let them go. but Hubble has already indicated the nucleus is likely kilometers wide. So, we are left with a single, unavoidable conclusion. The dust is almost exclusively composed of particles around 10 microns in size. This is the sweet spot that satisfies both the need to punch through solar wind and the limits of gas drag. Is this normal? The answer is a resounding no. We do not see comets dominated by 10-micron particles. The universe is filled with sub-micron dust. Finding an object that selectively ejects these heavy grains is like walking onto a beach and finding that, instead of sand, the shore is covered exclusively in marbles of the exact same size. It implies a sorting mechanism or a formation history that is entirely unique. There is only one other object in the records that showed a similar sunward glow, the comet Bernardinelli-Bernstein in 2014. But even that case was far weaker than the intense focused jet we are seeing with 3I Atlas. Loeb has proposed a natural origin theory, suggesting that perhaps 3I Atlas hails from a molecular cloud. In these dense, cold nurseries of stars, dust grains can stick together and grow over eons. Perhaps as this object drifted through the dark for billions of years, it accumulated a thick coat of these larger particles. This would offer a natural explanation for the anomaly. But if this is natural, the sheer volume of material being lost is staggering. The calculations indicate that the sunward jet alone contains about 10 million kilograms of dust. That is 10 quintillion individual particles. To produce the brightness we see, you would need a reflecting surface equivalent to a spherical mirror 20 kilometers wide. Since the particles are tiny, you need a billion times a billion of them to create that surface area. All of this material had to be replenished constantly. 3I Atlas is bleeding out. It is losing 3 kilograms of dust every single second just to keep that jet alive. And that is only the dust. The James Webb Space Telescope has measured the gas loss at 500 kilograms per second. The chemistry. 3I Atlas is not made of the stuff we expect. Normal comets are water worlds, dirty. Snowballs dominated by frozen H2O with a sprinkling of carbon dioxide. 3I Atlas has flipped this ratio on its head. It is releasing 8 times more carbon dioxide than water. It is a dry ice comet. In the history of astronomy, out of thousands of observed comets, only one other object, C 2016 R2 Pan-STARRS, has shown such an extreme inverted chemistry. And that comet was from our own solar system. 3I Atlas was born light years away. The statistical probability of an interstellar object having the exact same freakish chemical composition as a rare solar system anomaly is incredibly low. This carbon dioxide dominance might explain the large dust. CO2 sublimates at much colder temperatures than water. Perhaps this volatile, aggressive sublimation is what blasts the larger particles off the surface. Or perhaps it tells us that 3I Atlas was born in a star system fundamentally different from our own, a place where carbon was king. But the most disturbing detail, the one that keeps scientists awake at night, is the opacity of the cloud. The dust around 3I Atlas is not just thick, it is mathematically perfect. Loeb calculated the scattering probability, a number that determines how likely a photon of sunlight is to hit a dust particle. If the number is low, the cloud is transparent. If the number is high, the cloud is opaque. For 3I Atlas, the number is exactly 1. It sits precisely on the razor's edge between being a window and being a wall. This is a critical balance. If the cloud were any thicker, sunlight could not reach the surface to sublimate the ice, the gas flow would stop, and the dust ejection would cease. If the cloud were thinner, the process would accelerate. The system is maintaining a perfect equilibrium, allowing just enough light in to keep the engine running, but blocking enough to completely hide the machinery inside. For a natural object to maintain this optical depth of 1 seems like a miraculous coincidence. It is a self-regulating system that balances on a knife point. If the nucleus were smaller than a kilometer, the dust would choke the sunlight and the comet would die. If it were larger, the process would run away. The fact that it sits exactly at 1 forces us to ask difficult questions. If this is a natural comet, it is a 1 in a million roll of the cosmic dice. But if it is not natural, if we dare to consider the artificial hypothesis, then an optical depth of 1 is exactly what you would engineer. It creates a screen. It creates a shield that hides the object from external observation while allowing the system to function. Furthermore, the geometry of this cloud is suspicious. It extends 3,000 kilometers around the nucleus, but stretches nearly 1,000,000 kilometers toward the Sun. If you were an advanced civilization piloting an interstellar probe, this is exactly the kind of structure you would build. Space is not empty. At interstellar speeds of 60 kilometers per second, even a microscopic grain of dust hits with the force of a bullet. A collision with a grain of sand could vaporize a sensor. A trip through a dust cloud would be like flying through a barrage of anti-aircraft fire. To survive a journey between stars, you would need a shield. You would eject a cloud of plasma or dust ahead of your ship to sweep the path clear, vaporizing obstacles before they hit the hull. And you would orient this shield perpendicular to your motion and perpendicular to the Sun, to minimize resistance against the solar wind. The veil around 3I Atlas matches this engineering blueprint perfectly. It is a forward-facing bumper, a shield maintained across millions of kilometers, held steady despite the object rotating every 16 hours. Avi Loeb is a scientist first and foremost. He is careful to state that the most likely explanation is natural. He is not claiming this is an alien spacecraft, but he is fulfilling the duty of science by pointing out that the data does not fit the model. We have a list of 15 separate anomalies associated with 3I Atlas. The dust is 20 times too big. The scattering probability is exactly 1. The jet is focused like a laser. The chemistry is inverted. The mass loss is immense. The ratio of dust to gas matches the interstellar medium, not comets. The jet points at the Sun before and after perihelion. Any one of these would be a curiosity. All 15 of them together form a pattern that is becoming impossible to ignore. So where does this leave us? We are tracking an object that is surrounded by a cloud of impossibly large particles, hiding its true face behind a veil that is mathematically tuned to the perfect balance of transparency. We know it is shedding billions of kilograms of material, bleeding its mass into the void, while maintaining a structure that defies the chaotic influence of the solar wind. We know its chemical heart is alien to our understanding of cometary formation. The natural explanation requires us to believe in a chain of coincidences, that an ancient molecular cloud comet with a unique formation history traveled billions of years to display a freakish carbon chemistry and a dust particle size that mimics an engineered shield, all while balancing its optical depth perfectly on the edge of physics. The artificial explanation suggests that the dust is not a byproduct, but a feature, a protective screen designed to obscure and defend. Loeb is not asking us to choose a side yet. He is asking us to look at the evidence. The standard explanations are fraying at the edges. Every new measurement we take seems to widen the gap between what we expect and what we see. And the story is far from over. The universe is about to give us a second chance to solve this riddle. An international observation campaign is currently underway. The International Asteroid Warning Network is mobilizing a planetary defense campaign to harvest every photon of light from 3I Atlas between late 2025 and early 2026. This data will be the deciding factor. Avi Loeb has stated that he currently ranks 3I Atlas as a 4 out of 10 on his scale of anomalies, where 0 is a rock and 10 is confirmed technology. He has stated it will never drop below a 2, because the weirdness is already confirmed. But he is waiting. He is waiting to see if the new data pushes that number higher. The most critical date on the calendar is March 16, 2026. On that day, 3I Atlas will make its closest approach to Jupiter, passing at a distance of about 53 million miles. This is not just a flyby, it is a gravitational rendezvous. The object will pass almost exactly through Jupiter's Hill sphere, the region where the giant planet's gravity dominates over the Sun. This is the gravitational sweet spot. If you were a traveler looking to park a probe, release a satellite, or execute a maneuver with minimal energy, this is exactly where you would do it. It is the perfect celestial harbor. Scientists across the globe are preparing their instruments for this encounter. They will be watching for 3 specific events. First, they will look for course corrections, non-gravitational accelerations that cannot be explained by outgassing. Second, they will watch for separation events. Will any part of the object detach from the main body? And third, and perhaps most intriguingly, they will be scanning the space around Jupiter after the flyby to see if anything has been left behind, new satellites that were not there before. Whether 3I Atlas is a natural object from a bizarre, carbon-rich corner of the galaxy or a piece of technology traversing the stars with a dust shield, one thing is certain. It has humbled us. It has reminded us that our categorization of the universe is still in its infancy. We label things comet or asteroid because those are the boxes we have, but the universe is under no obligation to fit into our boxes. The dust veil of 3I Atlas is a curtain drawn across a mystery, and we are only just beginning to tug at the edges. As we wait for the data from 2026, we are left to wonder what lies behind the fog. Is it a rock? Or is it something that is watching Jupiter just as closely as we are watching it? If you want to be part of the conversation as we uncover the truth about 3I Atlas, and if you want to support the pursuit of these cosmic anomalies, leave a comment with your theory below. Is it a shield, or is it nature playing tricks on us? And don't forget to subscribe. The universe is getting stranger by the day, and we will be here to document every impossible moment of it.